We have something called the vertical line test, which when I talk about this, I abbreviate this as our VLT. And the vertical line test is the set of points in an XY plane is the graph of a function if and only if every vertical line intersects the graph in at most 1 point. Okay, this is another way to check, is it a function? This works when I have a graph. So you can see here, this is an example. This is called a parabola, this U-shaped graph. This parabola is not a function because when I use that vertical line test, I intersect that graph in 2 different spots. This one would be an example of a function. They only put 1 vertical line in here, but anywhere I put a vertical line, get my ruler here, anywhere that we put a vertical line in this graph, I am intersecting this graph in only 1 spot. So what we're essentially checking is, does my X repeat? You can see here, my X repeats because we have an ordered pair at 3, maybe 1/2 and 3, maybe -1/2. So that 3 is repeating on those ordered pairs. But when I put vertical lines in here and it never intersects more than once, that means my X isn't repeating. So example 4, 5, and 6, we're going to get a bunch of questions here. I'm going to, well, no, I'm not. Okay, so example 4. The graph below shows y as a function of x. Use the graph to answer parts A through E. So first, use the vertical line test to determine if this is a graph of a function. So I'm not going to put vertical lines in this, but you can see if I put a vertical line through this point, it only intersects that 1 point. Here, it only intersects the 1 point, only intersects the 1 point, the 1 point, the 1 point, the 1 point. So no matter where I put a vertical line, it's only going to encounter these random ordered pairs 1 time. So yes, this is a function. It passes the VLT, the vertical line test. So now, what is the domain? Your domain are your X values. So here, domain, we're going to go from the left to the right, and we are talking about our X values. So starting at this one here, I have an X value at -4. So I'm going to do my squiggly brackets, -4. Here's my next ordered pair. It has an X value at -2. Here we have an X value at 0. This one has an X value at 3. X value at 6. And lastly, an X value at 8. Okay, now I need my range. My range are all of my Y values. And to get my range, I'm going to go from the bottom to the top. Okay, so fancy squiggly brackets. When I start from the bottom, here's my first point, and that has a, now I'm looking at my Y values, has a Y value at -8. A Y value at -6, and I actually have 2 points right here with a Y value at -6. Continuing up, here we is our next one. I have a Y value right here at -2. Here I have a Y value at 0. And then lastly, a Y value at 2. And then fancy squiggly brackets. Okay, rewatch that if you need to. Now I'm going to evaluate f of 6. So this is my function notation. Now I don't know what the function is. So unlike On this one, I don't have a function to substitute in that value into x and evaluate the function. But what I do have are my ordered pairs. So if this represents my x, I'm going to go along my x axis right here to when x is 6. Find your graph. So I have no graph below, but I do have a point right here up above. So what is my y value when my x equals 6? Now I'll come over here, and that y value is 2. So this right here equals 2. Okay, why? Because this ordered pair is the ordered pair 6, 2. So my x equals 6, my y equals 2. Now, and this is actually supposed to be A through F. We'll fix that as well. A through F, I mean, honestly, have the same answers, or E and F have the same answers, honestly, as we go through these. Is 6 an input or an output? Well, we already said 6 right here was my x. X means input, and you can see right here, it is the x coordinate of this ordered pair. So this is an input. Is f of 6 an output or an input? This one is an output. Why? Because f of 6 equaled 2, and 2 is a y value. Okay, so when you have just a number, that represents your input, that represents your x. But when you have f of a number, that is always going to be your output because this equals something. This is a y value here that you're going to end up getting out. Okay. Now, rewatch this one if you need to, because we're going to go on to example 5. And it's going to get a little bit harder as we keep going through these problems here. Okay, example 4, were just ordered pairs. So really, that's almost no different than what we did in example 1. Now I'm going to take these 6 ordered pairs, and I'm going to connect them with a line. It doesn't look much different because you can still see we have all 6 of those ordered pairs, but when I connect them, it drastically changes my domain and my range. So now for example 5, use the vertical line test. Nothing changes with that because any vertical line I put through here is only going to intersect this graph in one spot. So this is still yes, a function. Okay, now what is my domain? This is going to be different here. On example 4, I could list out every number that was in my domain because it was just these 6 points. Even though these 6 points are still in my graph, I am talking about an infinite amount of x numbers here. If you just look between this point and this point, when these lines are drawn, I am now not just talking about x values of 3, 4, 5, and 6, but I'm talking about every number here between 4 and 5. So we're talking about 4.1, 4.2, 4.3, 4.4. We have an infinite amount of numbers in between all of these different points. So when I go over my domain, which is still my x, and we go from left to right, this is where it's really important to go from left to right and to kind of use a ruler here. Okay, as I go from left to right, where am I first encountering this graph at? So I have no graph, have no graph, have no graph. Here is where my graph starts. So if I do some dashed lines here, it starts here at -4. And because this point is included, it is a solid circle. We will put that in brackets. And then it has every number in between -4 to where? Where does this graph stop? It stops right here. At where? At 8. And then another bracket because that 8 is included. So let me get a couple pieces of paper real quick. So now I have my dashed lines here. We're talking about my domain has X values from everywhere from here to here, from -4 to 8, and every possible number in between. I am not looking at these numbers here. I am just looking at these X numbers on my X axis. Let's try this again with my Y. For my Y, this is my range. We're talking about my Y value. So now I'm looking at the Y's, and we're going to go from the bottom to the top. So as I go from the bottom to the top, where do I first encounter this graph? Here's where my graph starts, and I have a Y value at -8. So we're going -8, 2, and then keep going. I have Y values. Where does the top of this graph? Y values. And here's where my graph stops. Once I get past 2, I now have no graph. So this is the top of my graph where I have a Y value at 2. And that is included. The same concept. Here is where my graph lives. I'm not looking at my X values, at only my Y values. My graph lives from -8 to 2. And it has Y values all in between. Again, just from this point to this point, -6 to 0, we have every number in between. We're going to be doing a lot of these kinds of domains and ranges from graphs, not usually ordered pairs. So we do want to get really good at this right here. All right. So another typo here. I thought I changed this before I printed. I guess I did not. These are supposed to be -2. I will do my darndest, guys, to make sure that every lesson is not filled with typos. Okay, but yours should say f of -2. So evaluate f at -2. So let's just use a different color since I've already used red and blue on this graph. So f of -2, this is representing my x. And pretend like that's an x there. So I'm going to go along my x-axis here to where x is -2. Meet your graph. I have no graph above, so I am going to go down below. Here's where my graph is. What is my y value when I have an x value of -2? That is at -8. And why? Because this ordered pair here is -2, -8. So is -2 an input or an output? Well, that's what we put in for x. So that is an input. F of -2 is then what? Well, f of -2 equaled a number, and that was my y number, which represents my output. Okay, one more example. Example 6, asking the same things. Now, these graphs are almost the exact same. What's the difference here? The difference is this one had a clear start to the graph and a clear end. So I knew it started right here at the ordered pair -4, -6, and it ends at 8, -2. This one has arrows. That means it's going to keep going in both directions. So how does that change this? Okay. The vertical line test still only intersects that graph in one spot. So yes, this is a function still. So in fact, the only example I have of a graph not being a function is this one right here. So when we can put a vertical line and it hits it twice, that means it's not a function. But if you put vertical lines and it only intersects once, the way all of our examples have been, then yes, it's a function. Okay, what's the domain? Domain is my x, and we go from left to right. Now, as I go from left to right, the first thing I encounter is an arrow. Arrows are going to mean infinities. So this one is negative infinity because of this arrow. And as it keeps going, we encounter an arrow at the end, and that's going to mean positive infinity. So my domain is all real numbers, negative infinity to positive infinity. So why do arrows mean infinity? Well, because it means that this graph is not starting and stopping at these points, right? This graph is going to continue on forever, which means you can see as it continues up and over, it's going to keep touching all of these x values. So can I eventually get to -15? Yeah, extend this out a little bit more. Can I eventually get to -20? Yeah, keep extending. Can I get to a -100? Well, that might have to go quite a bit, but yeah, I can theoretically eventually get there. Same thing with this one. It's going to keep going forever, right? So as this is going down, I am now getting an x value of 10, at 12, at 14. Can I eventually get one at positive 20? Yeah, expand this out some more, and we're going to eventually get to 20, right? So as arrows means it's going to keep going, and so that's my negative and positive infinity. Very similarly with this range now. I have range is y, and we're going to go from the bottom to the top. And as I go from the bottom to the top, that first thing I encounter is an arrow, which means it's going to keep going down forever. So we got negative infinity. Oop, that's bad. And then it's going to keep going up forever. So positive infinity. It's going to go down on that y forever, and it's going to go up on that y also forever. Okay, so now D, let's evaluate. Again, so sorry. Okay. And yours says a number. What's the number? 0. Zeros are always kind of tricky, it seems like. Okay. Okay, so if I want to evaluate f of 0, this is representing my x. So go along your x-axis to when x is 0. I have no graph above it again, so we're going down below. There is my point. What is that y value when my x is 0? It's right here at -6. Okay, because this ordered pair is 0, -6. So x is my input, which answers this one. 0 is your input. F of 0 equaled -6, which is my y. This is my output. Okay. These questions, specifically 5 and 6, are going to be big questions kind of going forward. So I highly recommend you rewatch them if you need to make sure you understand them. We will be answering domain and ranges specifically as we continue on in this class.